Hey there, future statisticians! Are you ready to dive into the fascinating world of numbers and patterns? Bill Nye here, ready to unravel the mysteries of the standard normal distribution. It's a concept that might sound intimidating at first, but trust me, it's a lot simpler than it seems. Sounds complicated? Don't worry, it's as easy as pie, and just as much fun. Imagine slicing a pie into equal parts. That's how we break down data. Imagine a roller coaster. The highest point is like the average height of all the riders. It's the peak where most people are. Most riders will be around that average height, right? That's the mean. It's the central point where most data points gather. Now, as the roller coaster goes up and down, fewer and fewer riders are at those heights. This represents the extremes in our data. That's like the normal distribution. Most things in life cluster around the average, forming a bell shape. This bell curve is a visual representation of how data is spread out. Think about shoe sizes. Most people wear shoes around the average size, with fewer people having very small or very large feet. This is another example of the bell curve in action. This creates a bell curve. The majority of people fall within the middle range, while the extremes are less common. We see this pattern everywhere, from the heights of sunflowers to the scores on a spelling test. Whether it's nature or academics, the bell curve helps us understand the distribution of data. So next time you see a group of kids, a field of flowers, or even a collection of test scores, remember the bell curve. It's a powerful tool that helps us make sense of the world around us. Now let's talk about how spread out our data is. We call this standard deviation. Think of it like this. You and your friends love pizza, but you don't all eat the same amount. Let's say the average number of slices everyone eats is 3. But some friends might eat 2 or 4 slices, and some might even eat 1 or 5. The standard deviation tells us how much these pizza eating habits vary. A small standard deviation means everyone eats a similar amount, while a large one means there's a wider range of pizza appetites. Ever wanted to be a data detective? Well, here's your secret weapon. Z-scores. These little guys tell us how far away a specific data point is from the average, measured in standard deviations. Think of it like this. You're at the amusement park and the average wait time for a ride is 30 minutes. But you find a ride with only a 15-minute wait. That's a Z-score of -1, meaning it's one standard deviation below the average wait time. You're a ride-waiting champion. Z-scores help us compare things that might seem different at first glance. For example, is getting a 90 on a history test better than getting an 85 on a math test? Z-scores can help us figure that out. Let's compare apples to apples. Imagine trying to compare a watermelon and a grape. They're both fruits, but they're very different sizes. That's where standardizing comes in. It's like using a special measuring tape that lets us compare things on a level playing field. By converting our data to Z-scores, we're essentially putting everything on the same scale. This helps us see patterns and relationships that might not be obvious otherwise. It's like having a superpower that lets you see the world through data-colored glasses. Section 5, Sweet Success, the Candy Factory Conundrum. Let's take a delightful journey into a candy factory where they make bags of colorful candies. It's a place filled with sugary magic and meticulous processes. The goal is to ensure every bag has the same amount of candies, but, sometimes the machines get a little wonky and things don't go as planned. This is where our statistical skills come in handy. By using statistics, we can solve the conundrum and ensure consistency. Let's say the average bag should have 50 candies. This is our target number, the sweet spot, if you will. By measuring the number of candies in a bunch of bags, we can create a bell curve. This graph helps us visualize the distribution of candies. The center of the curve represents our average of 50 candies. It's the peak where most of our data points lie. Now, if the standard deviation is small, it means most bags have a number of candies close to 50. This indicates consistency and reliability in the candy-making process. But if the standard deviation is large, it means some bags might have way more or way fewer candies than 50. This variability is no good for candy lovers who expect uniformity in every bag they open. By understanding and applying these statistical concepts, we can ensure that every candy lover gets a fair share of sweetness in each bag. And that, my friends, is the sweet success of solving the Candy Factory conundrum. Section 6. Weighing the options. A balancing act for candy lovers. The Candy Factory has a problem. Too many bags have too few candies. This inconsistency is causing a lot of headaches for both the factory workers and the candy lovers who expect a fair share in every bag. How can they fix it? They have two options. 1. Adjust the mean. This means they could change the average number of candies in each bag. They could adjust the machines to put slightly more candies in each bag, maybe 52 instead of 50. This small change could make a big difference in customer satisfaction. This would shift the whole bell curve over a bit, ensuring that more bags meet the expected candy count. 2. Reduce the spread. They could try to make the machines more precise so the number of candies in each bag is closer to 50. This involves fine-tuning the equipment to minimize variation. This would make the bell curve taller and narrower, indicating that most bags have a candy count very close to the target number. Which option is better? It depends on various factors. Sometimes, adjusting the mean is easier and cheaper. It requires less precision and can be implemented quickly. But if they really want to make sure every candy lover gets a fair share, they'll need to reduce the spread. This ensures that each bag is as close to perfect as possible, making every candy lover happy. Ultimately, the goal is to find the right balance so every candy lover gets their fair share of sweetness in every bag. Section 7. The Power of Prediction. Unlocking the Future with Statistics. One of the coolest things about the standard normal distribution is that it helps us make predictions. By understanding the bell curve and using z-scores, we can estimate the probability of something happening in the future. For example, let's say you're trying to guess how many people will come to the school dance. By looking at the attendance numbers from past dances, you can create a bell curve and calculate the probability of different attendance levels. It won't be perfect, but it's a lot better than just guessing. Section 8. Keep exploring. The adventure continues. Congratulations, data detectives. You've unlocked the secrets of the standard normal distribution. But this is just the beginning. There's a whole world of statistics out there, just waiting to be explored. So put on your thinking caps, grab your calculators, and get ready for an adventure in data analysis. Who knows what amazing discoveries you'll make? Section 9. Glossary Big Words Made Easy. Normal distribution. A fancy way of saying that data often forms a bell-shaped curve with most values clustering around the average. Mean, the average of a set of numbers. Standard deviation, a measure of how spread out the data is. Z-score, a measure of how far away a specific data point is from the average, measured in standard deviations. Standardize, to convert data to z-scores, putting everything on the same scale.